This is how to derive or prove Pythagorean theorem. You can use a square or a rectangle. I'm going to use a rectangle just to show how it doesn't matter. Divide it down the middle. I'll call the narrow angle alpha, the wide one beta. Side A will be next to alpha, B will be next to beta, hypotenuse will be C. If this side is A, this side is identical length, it has to be A, likewise with B. If alpha lies between A and C, then here's A and here's C, so that means this has to be alpha. Likewise, this has to be beta. Make that a little better, beta, so it doesn't look like my side B there. So, proving the angles, proving the sides. What we do now is we take these two triangles, we open it up in the middle, so we'll have side A right next to side B, forming a straight line, just like that. Notice A sits next to B, alpha sits next to beta, just like right here, alpha sits next to beta. Side C is the hypotenuse. Let's prove side gamma. Let's prove that it is a 90-degree angle. The interior angles of a triangle have to add up to 180 degrees. Alpha, beta, 90. Alpha, beta, 90, 180. See my other video for the proof of the interior angles of a triangle. It's really easy. And I'm not just saying that to sound smart. I mean, it's a really easy proof. Okay, subtract 90 from both sides. Therefore, alpha plus beta has to equal 90. Alpha beta has to equal 90. Alpha beta has to equal 90. That means this right here, this angle alpha plus this angle beta has to equal 90. This straight line equals 180 degrees, just as the definition of a straight line. So alpha plus gamma plus beta has to equal 180 degrees for that straight line. Alpha plus beta plus gamma has to equal 180. We've already proven right here that alpha plus beta has to equal 90. So we just turn this into 90. 90 plus gamma has to equal 180. That means gamma has to equal 90. And it just has to be that way. So you're going to get this as long as you put A next to B. So my next proof on how to do this wrong may be superfluous, but I think it's interesting to look at the wrong way to do things and to show why they're wrong. Because personally, when I first figured this out, I wanted to stick A next to A or B next to B, and so I needed a proof of why I either could or could not do that. So let's mosey on over to here. Here I stuck A next to A instead of A next to B. So you notice we got the two long sides together instead of a long side and a short side. I guess I did good by using a rectangle instead of a square. That way we get a long side and a short side. So yeah, that worked out. Okay, so the side alpha here, or the angle alpha, is right next to A, right there and there. This is 180 degrees. Quick logic check might tell you that alpha can equal anything between 0 and 90 degrees. This line alpha could go from here, it could go up to there, it could go all the way to here. You could have both angles alpha being 90 degrees. But if you want to do a quick proof, 2 alpha plus gamma, alpha and alpha is 2 alpha, we'll call this whole thing here gamma, has to equal 180 degrees. Notice we have two unknowns, both alpha and gamma, thus showing that this line can come all the way from 0 down to 90, and the same way with this angle right here. So now that we've proven this is the way it has to be set up, A next to B, let's just do this, and then let's put another triangle here and another one here, and notice it'll form a perfect big square with a little square inside of it. A goes next to B the whole way around. When I first learned this or figured this out many years ago, I might have accidentally tried to put A next to A, I don't remember, but I remember it was a tough call because I didn't know what I was doing. Okay, so now that we've properly built our big box and our little box, let's go through the proof of Pythagorean theorem, just some quick algebra. The big square is going to be A plus B, quantity squared, A plus B, and then times A plus B. So this will give you the area of the big square. I guess I should have written area here. area right there. The area of the little square is going to equal c squared. C times c. Now we're going to use our official math notation here. The big square minus the area of the big square, which is this whole thing, minus the area of these little triangles, times 4, because there's 4 of them, will give you the area of this little square. Because notice the only thing between the big square and the little square is 4 triangles. So big square is a plus b quantity squared. Right there, that's the area minus the area of a triangle, 1/2 base times height. So 1/2 AB. We have to multiply that by 4 though, because we have 4 of those. So multiply that by 4 equals c squared, which is the area of the little square. FOIL that out. A squared plus 2ab plus b squared minus 4 divided by 2 is 2ab equals c squared. Positive 2ab, negative 2ab cancels out. A squared plus b squared equals c squared. Feel free to see my other video where I used Pythagorean theorem to derive pi. I just recently discovered that there's a name for that term, and it's called the method of exhaustion or method of Archimedes. So yeah, I didn't know that at the time. I was just trying to figure it out. So that's it.